matter around us is made up of atoms. That actually means atoms combines together to build matter. But the question is, how does these atoms combine together? What is that something which is keeping them together? So basically, like we humans, we make different kind of connections in our life. Like with our parents, we have a different kind of connection. With our siblings, we have a different kind of connection. And with our friends, there is entirely different kind of connection, right? Similarly, these atoms make different kind of connections with various atoms to make this entire matter around us. So today we will be discussing one such kind of connection which atoms make, and the name is ionic. To make you understand this topic, I have already took an example here, which is sodium and chlorine. Sodium has atomic number 11, right? What does that mean? What does this mean that an atom is possessing 11 atomic number? Correct. Number of protons, which means sodium have 11 protons present inside its nucleus. We already know atom has a solar system kind of arrangement where inside the nucleus, in this at the center of the atom, there are protons, and around it there are shells where electrons reside. We already know that. To balance this 11 positive, there is equal amount of 11 negative. So they just cancels out each other, making the entire atom electrically neutral, right? Similarly, chlorine, 17 protons inside the nucleus, and in the orbits, there will be 17 electrons. Basically, atom is electrically neutral. Now, when I say these electrons reside inside the orbits, every orbit has its own capacity to accommodate a definite number of electrons. And how do we find it? Do you remember? Pi 2n square. If I put the value 1, then it will be 2 1 square, which is the first shell. Number of electrons will be 2. If I put the value 2, then it will be 8. Value 3, the answer will be 18, and so on. This is the capacity of first shell, which is K, second shell, which is L, third shell, which is N. Right? Let's just focus back on our example. Talking about sodium, which has 11 electron. Mind you, it can accommodate 2 electrons in the K shell. We are still left with 9 more. 8 electrons in the L shell. We are still left with 1 more. M shell will require 1 electron. This is the electronic arrangement, which I have already shown in the diagram. You can observe that as well. Talking about chlorine, K shell will accommodate 2. We are still left with 15. L shell will acquire 8, and M, 7 electrons will be accommodated. Now, like we humans, we need stability in our life. By the way, what does stability mean to us as humans? It is maybe a huge or maybe a decent amount of bank balance, a luxurious house, a luxurious car, decent lifestyle, maybe. That is our stability criteria. Similarly, these atoms also have their own stability criteria, and that says that their outermost, which one? Outermost orbit should have 8 electrons. If this happens somehow, they will acquire the stability. Think about sodium. Is it stable? I don't think so, because there is only 1 electron in the outermost shell. Chlorine is also not stable. There is only 7 electrons in the valence shell. So both these atoms, which I have took as example, are already unstable. So what they need to do to become stable? Let's talk about that. I'm talking about chlorine first. It just requires 1 electron, because it is just short of 1 electron to make it 8, right? Talking about sodium, it has to bring in 7 more electrons, which is a huge number, by the way, and that is not possible. Let me show you why that is not possible for sodium. What is possible for chlorine? See, for sodium, there are 11 negative present inside the atom, and it is trying to bring in 7 more negative. For the sake of understanding, I'm replacing electron with negative. So about chlorine, there is already 17 negative present, and it is trying to bring in 1 more negative from outside. Now just try to understand 11, which is already present, and 7, which sodium is trying to bring in. Both of these numbers are somewhat comparable, 11 and 7. Look at the chlorine, there are 17 and just 1 it is trying to bring in. So 1 is very small number in front of 17. These are not comparable, right? So the repulsion between like charges, that is negative and negative in case of chlorine, it will be very less, very negligible. But talking about sodium, the repulsion between these charges, the 11 negative and 7 negative will be huge, and they will be repelling each other, and it cannot add 7 more electrons in its orbit. So this is not possible. Now sodium is wondering and thinking, if I may not be able to get stable ever in my life. While it was thinking about this, sodium just ended up getting an idea, and the idea was, let me share it with you. that this outermost electron, if I may throw this electron away, then my outermost shell, which is M, it will become vacant, correct? And then it means the outermost shell will be L. L has already 8 electrons. Criteria was 8 electrons. And that's how sodium can become stable, which is actually a great idea. But as we know that sodium is now ready to donate one electron or lose one electron, so it will be looking for someone who require one electron. And what better than chlorine, which is present there right next to sodium. So what sodium and chlorine do, they just end up signing a deal with each other, where sodium transfers its one electron to the other. How the situation will look like post that transfer of electron, let me show you. Talking about sodium, initially it had 11 protons, which are still same, but the electrons will be 10 because one electron has been transferred. Talking about chlorine, initially 17 protons was there, which are still same, but electrons will be 18 now because one electron it has accepted from sodium. So who will win the battle in case of sodium? Obviously, positive. Proton will be winning the battle. By how much margin? Just one. In case of chlorine, negative will be winning the battle because 18 is the bigger number by one margin. So these particles, which were atoms? Yes, were atoms, because now they have acquired charge. To acquire stability, they are become ion. When a particle is electrically neutral, it is called atom, but as they have acquired charges now, they are not atoms anymore, they are ions now. They have got a new name. And these opposite charges will attract each other, making a connection where these ions will end up staying together due to attraction. And this attraction is called as ionic bond because it is in between the ions.